Well, good afternoon. I can promise you we have a really fun and energetic group coming next, so we'll all wake you right up from that lunch break. I'm Lisa Dixon. I'm Vice President of Sustainability for Kleinfelder. We've had the good fortune of being involved with quite a few climate change studies in this area and other places for the last 3 to 5 years. Very excited about this panel. We're going to be focusing on the built environment. So we have the climate change science, we have the risk associated with it, and then how does it interface with the built infrastructure. For speakers, same overall presentation mode as we saw earlier today. I'll have each of them come up and talk for about 20 minutes on their particular area of expertise, and then we'll open it up to panel discussion. So the first speaker we have today is Mike Benedetto from Skanska. He is the director of the consulting group there, and he's going to be talking about some of the challenges of accommodating climate change from a developer's perspective. Mike?
Well, thank you very much, Lisa. It's a pleasure to be here. I know this is a very important topic, and it's on the forefront of a lot of the daily conversations, both in the general media, in the business environment, and happily in academia as well. A lot of the genesis of the information is coming from that, and we're all very thankful for that. Just a couple of things to get started. As Lisa mentioned, we want to narrow this a little bit for this afternoon session. It's such a broad topic that we want to zero in on what are the adaptations that make sense, what are the ones that are going to give us the most bang for our buck. And as an owner of an individual building, a group of buildings, a campus such as this, a major infrastructure system, what are the things that, as a manager and an asset owner, what are the things that need to be done? Where are those precious dollars spent to get the most bang for the buck to avoid some of the problems that we've seen? A couple of things that just observations, right? The scale and magnitude of the events that we've been seeing, I don't know if unprecedented is the right word, but certainly in recent memory, they are significant. Those are our starting points. When those events occur, we have outcomes that aren't really that great. Outside of the financial impact and the individual tragedies, these are just not good outcomes. This is just a local, this is not superstorm related. This was a communications tower for a municipality in the western part of the state. Came down in a windstorm. I'll refer back to that in a little bit. Just other things, when we are looking at our buildings, they're not performing, they're not holding up to these events. We're asking, in the course of these events, we're asking these buildings to do things that they were never intended for. And we need to understand that and think about those adaptations and what we can do to make sure that they perform as we need them to. These are just some of the responses that we get. And the point is that not all of this is Katrina and Sandy and Irene level. There's climate response that has a lot of different dimensions to it. It's both big and small, and both of those are significant, and both of those factor into what it is that we need to be doing and looking at. The current approaches for buildings, when we think about how a building needs to perform, some of the design parameters in that paradigm is don't fall down, burn slow enough so that the people can get out. Those are some of the, at the very high level, That's what we're looking at from a design standpoint. We take all the critical aspects of the building, and what do? We put them in the basement so we can get to them. We co-locate them for serviceability and for maintenance and for, quite honestly, length of primary electrical distribution runs, right? Those are some of the drivers that lead us to have the built environment look the way it does, and consequently, as we've seen, perform the way it does in some of these events. So we need to look at the way the buildings are set up. They're meant to respond to internal situations. They're not really good at responding to external catastrophic events, catastrophes. So we've got to flip that around. That's one of the directional things that, from an industry standpoint, that's being looked at. You know, the other piece is when we are doing a critical system or building a building, it's always, you know, will it operate in an island mode? That's something that is becoming much more predominant in the thinking. You know, it used to be that dual electrical feeds were, you know, I've got 2 substations, what could go wrong? Cogeneration, self-sustaining, you know, for critical assets. Those are some of the things that are being considered. You know, one of the big drivers in the microgeneration is to be able to operate and withstand. We have some projects and some client groups that are looking at combined bioprocess technologies that will generate fuel and food. And they want to have those on their campus so that in an extended period of outage, you know, they really can survive that for an extended duration. And then the other aspect of that is that there's outgrowths of that translate over into a regional. Now they can be a center during some of these crises and sustain populations larger than just the building occupants. So those are that shift that we see in some of these and what is being thought of and looked at. So the question becomes, how do we take where we are today and how do we, you know, the current state to the future state? It's not easy. There's predictive modeling that thankfully we now have the benefit of and is just getting more and more accurate all the time. It's still predictive modeling. And within that, inherent in that is uncertainty. The other dimension is we don't know precisely what will happen and when it will happen. So we have uncertainty as around the more tangible, what we hope to be the more tangible aspect of what do we really need to plan for. So we have a couple of layers, multiple dimensions of uncertainty, and we've got to figure out a way to plug in some of those variables so that we can find a model and we can build an equation that will give us an answer. How many people have tried to change somebody's mind and failed? Okay. I'm sure there's lots of people here that are trying to do that within their own organizations or groups or civic clubs. It's very difficult. There's a lot of barriers. Status quo has a lot of momentum. We're now asking for capital. We're asking for changes in operating procedures. We're asking organizations to do things different, and it's just plain difficult. If we overlay that into the business environment, capital absolutely at a premium. Even manage investment and organizationally and from a management perspective is difficult to garner. There's conversations that I've seen where, you get a little momentum around the adaptation. We've had, it's a topic in the news and how do we prepare. And then you'll get down the road and then people will start to say, yeah, but we're a healthcare system and so our dollars need to go to patient care. Or we're a learning institution and our dollars need to go to the students. And we're trying to plan for and address these things that are somewhat abstract and trying to get and focus those dollars for that. We'll talk in a minute about how do you quantify. If I'm going to barricade my building so water isn't going to come in, how do I quantify that? How do I make the business case, quite simply, how do I make the business case to my boss so that we can go get a design and a study going so that we can actually implement some of these changes? Very difficult to do. We'll talk about some of the techniques that we think are appropriate and we think give us some answers to that. But it's not an easy thing to do. Trying to take, a business case decision, look at what are the costs of doing nothing. That has to enter into the calculation. And so if you take a step back, I've got events that I don't know that I think are coming. I don't know when. I don't know how severe they're going to be. I have the cost of doing nothing, which that's hard to get folks to quantify and address and appreciate. And now I've got to put capital and drive an organization in that direction. So you can see some of these things, the complexities, how they compound themselves. The process that we go through is fairly straightforward. It's how you would in either a business perspective or a scientific perspective or an engineering perspective. You define the problem, you break it into bite-sized pieces, and it just kind of goes through. You review the client science, you look at what are the observations, what has my campus infrastructure system, building experienced recently. If something that happened in another region were to happen here, how would the building respond? So that is the way that the conversation kicks off and gets started. You address and look for vulnerabilities within your system. You scenario play. You run through and look at how would you operate if the grid went down, if the gas main was off, if the road transportation was out, if my supply chain was interrupted. And you just walk through those things and you develop your adaptation, right? What do you want to do and how are you going to address those scenarios? The last two are really now we're cooking here because we've got to quantify it and then we've got to implement it. And then like any good process, right, we want to learn from the results, we want to monitor it, and we want to approve, and we go back up to the top. And each time, in theory anyway, we get smarter about how we address these things. As I mentioned before, there's really two main aspects to this. We have the identification of the adaptation. What is it? When does it happen? What do I need to do? And then we have to quantify it. And so when we look to evaluate these impacts and overlay them against the vulnerabilities, we want to have a little structured decision making so that we can rank some of those. We want to rank our vulnerabilities. We want to rank what the potential impacts are, and we want to line those up. Once we do that, the next piece of it is really it's some straightforward financial calculations. They're kind of paybacks, cost-benefit analyses. Those are the type of things. And when we put those two together, we hope that that gives us some guidance and some indication as to where we want to invest our efforts. A couple of tools, I'm sure folks are fairly familiar with them. There's actually others. These are the ones that I've seen in practice. And I can tell you there's some creativity that goes in to these as well. We will look to borrow techniques from other industries. So the tracer analysis, for example, from the healthcare, and you follow a patient or even in a manufacturing process, you follow that through the chain and you look at how it's impacted under the different scenarios. Down in a hard asset environment, we look at impact assessments. That's a technique from really biopharma and aerospace, where you have to work in a highly regulated, highly qualified environment. And so you have to understand down at the, in those cases, down at the valve and instrument level, you know, if temperature sensor T101 goes out, what happens and what are the cascading effects. So those are some of the ways that we can take this very large problem and peel it down and make some sense out of it. As I mentioned before, the data, thankfully, we now have access to some of the best data ever. It's really about translating that data and manipulating it, organizing it in order to, you know, it's the data versus information, right? We want to take the data and turn it into information. When we get into the financial aspects, there's a lot of pieces, and as I mentioned in the beginning, for the purposes of the scope of this discussion, we're talking about impacts to a particular building or system. We're not talking about regional impacts. When you start to get into economic analyses and more macro level, it gets even more complex. So we just want to look at, you know, as a finite asset owner, what are the things that I need to consider? And so when we're looking at a meter sea level rise, what does that mean to my building? Okay, so that's halfway up the door. I get it. I can see that. But what then does that mean? And what is the impacts to operations? What is the measurement against the cost of doing nothing? And we want to look at not only the primary impacts, but secondary and even tertiary impacts. And those will go into the calculations, and it's really you net those out. So you will look at the hard aspects of the infrastructure. What does it cost to barricade the doors? You net that against your scenarios and the cost of doing nothing and disruption, business continuity risk. If you have a public service mission, you have to look at what are the replacement costs of that service, and you net those out and do some relatively familiar calculations in terms of payback, and you can gauge, and that can guide you. One important point here. I'm going to maybe take a step back after I say this, but you don't have to be right. You just have to be close, because this is not about, in absolute terms, what is it going to cost for 3 meters of water on my doors, right? You have to understand, if you remember, we're thinking about guiding infrastructure investment, guiding adaptation investment. We have to be accurate on relative terms. We don't have to be accurate in absolute terms. So that's an important point, and really one that some of these structured decision models are really geared to, because they're all sort of fundamentally on a weighted average type of a basis. As you're going through and looking at what the responses are, look for the triggers. That's an important point. There's going to be, that building and that infrastructure system is going to be able to absorb a certain amount of climate impact. But there'll be a point at time when, okay, your electrical gear floods, right? There'll be triggers. There's a breach in the building perimeter. Those are going to be the things that you're going to want to key in on. And then the other thing, on the other side, on the opportunity side, where are the adaptations that get me duplicate benefits? Where can I kill two birds with one stone, with one adaptation measure? Those are some of the things that you want to look for. So this is a sample of the decision-making matrix. You can see it's fairly straightforward. It's really meant to guide individual or a group through the process and take it really to wring out some of the subjectivity. This is one of the examples. You can just see it's just adaptation measure. It's just a 2D, right? Adaptation measure and scenario horizontally across the top. I apologize. I know you can't read it. And you go through the weighting, and that will sort of guide you on some of the decisions. Again, this can get complicated. A couple of the things that are not being considered here are some of those macro components. And then in the financial calculations, it's really benefit minus cost over, period of time. Let the computer do the iterations, and a discount rate. And that's really, you can start to see what makes sense in terms of for an investment and where you should put the money. The other piece is that as you go through in that chain of evaluation, you want to look at this from a couple of different directions. A lot of times these are you forward passes through a scenario and then you do a backward pass. What I think was most effective here is start with the impact, right? So it's a backward pass and then a forward pass through the analysis. Again, abstract concepts, you need to make it real, put it in some very finite and quantifiable terms. You want to elicit as much organizational support, understand that it's not going to come easy, and really look for, on a relative basis, which of the measures are going to protect your property, your people, and your business operations. So I think with that, we have questions.
No, at the end.
We'll do questions at the end.
Thanks, Mike.
All right, thank you.